Hi guys, this is Jonathan Lambert with the Mathematics Development and Support Service at National College of Ireland. And this short video, another video in our series of videos dealing with the binomial distribution and in particular calculating binomial probabilities, is going to just move on from, I suppose, it's going to do another probability calculation based off the scenario that we've concentrated on in the last couple of videos. And let's just, I suppose, refresh the scenario itself. A bank estimates that there is a 30% probability that each loan will not be repaid. Okay, so with respect to this particular bank, we know that there's a 30% likelihood that loans will not be repaid, and that's important here. The context of the question is with respect to loans not being repaid. This 30 is got to do with something not being repaid. Okay. And we also know that the payback probability for each loan is independent of each other, which is important for the binomial distribution formula. And what we also know is that in a particular week that the bank has given out 10 loans. So it has given out 10 loans, if that makes sense. Okay. And we want to calculate what's the probability that all the loans will be repaid. Okay. Now, from the binomial distribution formula perspective, we have that the probability that the binomial variable takes on a specific value is equal to ncx times p to the power of x times 1 minus p to the power of n minus x. This allows us to calculate the actual probability. And you can see that there's a number of things in here that we have, number of values. There's n, okay, there's p, and there's x, okay. N is the total number of objects that we have, or observations. In this case, we've given out 10 loans, so N is equal to 10. Okay. P is the probability of success or failure. Now, the probabilities that we're talking about here, there's a probability of a 30% likelihood that the loans will not be repaid. So this probability P is 0.3, and it's got to do with not repaid. Okay, that's the probability that we're dealing with here. And x then is the number of objects, okay, out of the 10 objects, okay, that take on this particular characteristic, okay. In this case, that take on the number of objects that take on not being repaid, okay. So we want to calculate what is the probability that all loans will be repaid, okay. So let's think about this here. When x is 0 in this context here, what it means is that 0 loans are not repaid. When x is 1, it means that 1 loan is not repaid. When x is 2, it means that 2 loans are not repaid. When x is 9, it means 9 of the loans are not repaid. And when x is 10, it means that 10 of the loans are not repaid. Now, we want to figure out the probability that all loans will be repaid. Okay, so all loans will be repaid means that 0 loans have not been repaid. Okay, 0 loans have not been repaid means that all the loans have been repaid. So in this case here, the x is 0. Okay, that's what we need to calculate, the probability. Right? And the probability that 0 loans are not repaid. So actually, what we end up with is we calculate the probability that out of the 10 loans, that 0 of them are not repaid, and that's equal to ncx, which is 10c0 in our case, because x is taken on 0, times p, which is 0.3, raised to the power of x, which is 0, times 1 minus 0.3 raised to the power of n minus x, which is 10 minus 0, which is 10 minus 0 here. Okay. Now, we'll just calculate these all in one go. 10c0 is 1. Okay, let's just do it on the calculator here so that you can actually, you can trust me on this. So 10, second function, the NCR button, 0, is equal to 1. So this actually becomes 1. Okay, and any number raised to the power of 0 is also equal to 1. And this is 1 minus 0.3 gives us 0.7, which needs to be raised to the power of 10. So in our case, it's 1 times 0.7 to the 10 is the same as 0.7 to the power of 10, which gives us a value of, well, 0.7 raised to the power of 10. It gives us a value of 0.02824, or 0.0282 is the probability that all loans will be repaid. In other words, that x is equal to 0. Context is important here. Let's just do one more example here while we're looking at this. Okay, what is the probability that I suppose that all of the loans will not be repaid? Okay, so in this case here, let's just have a look at this. The question is, what is the probability okay, that all the loans will not be repaid. Okay, and this is the context of the question. Okay, now once again we know that n is equal to 10. We know that p is equal to 0.3, and that context is about not being repaid. Okay, and also what we know, well, what we have to figure out is x. Okay, so all the loans are not repaid. Okay, which means context not repaid. So x is the context. All of them, all of the n are not repaid, which means that 10 are not repaid, means all of them. So actually what we calculate is the probability that x is equal to 10, which is equal to NCX. Okay, don't forget the formula. The probability that x, the random variable, takes on a specific value, small x, is NCX times p to the power of x times 1 minus p to the power of n minus x. Okay, so we calculate this value here, which is when x is 10, so this becomes 10c10, because n is 10 and x is 10, times 0.3 raised to the power of 10 times 1 minus 0.3 raised to the power of 10 minus 10. Now 10c10 is just equal to 1 as well. Let's just sanity check that. So I'm putting in 10, shift the 5 button, which brings up the combinations formula. So that's 10c10 is, you can see that's equal to 1 as well. Okay, so that's equal to 1, okay, times 0.3 raised to the power of 10 times 0.7 raised to the power of 10 minus 10 is 0, which is just effectively equal to 1. So this is equal to 0.3 raised to the power of 10, which gives us a value of 0.3 raised to the power of 10 is equal to, it's tiny, okay, it's equal to 0.0000, many decimals, 0.0000. It's effectively equal to 0. No, it's not really. You can see actually that it's 0.00005904. Okay, it's tiny. Okay, the likelihood that if I give out 10 loans that they all won't be repaid is tiny. It's effectively equal to 0. Okay, it's effectively equal to 0 there. Okay guys, once again this was Jonathan Lambert with the Mathematics Development and Support Service at National College of Ireland, and I hope that this video was intuitive. More importantly, I hope that was helpful, and once again thank you for watching. Okay, bye bye.